Next, we're going to move on to linear inequalities. So we just finished studying linear equations. Now, instead of having an equal sign in between two linear expressions, we're going to have inequality symbol. So less than, greater than, not equal to, that sort of thing. And then the equal to versions, I should say. And perhaps even not equal. Okay. Really, our goal, solve for one variable in a linear inequality, and maybe even some of those in context. And so we're going to look at how to solve these inequalities, and then talk about how to use a number line to represent the solutions algebraically, and also interval notation. We're going to see compound linear inequalities, and then of course everything that we do we want to try to apply. So we're going to do some written descriptions, and also talking about context stuff too. Okay, just be aware that Hawks does have a section in here about absolute value linear inequalities. You never ever use them in life. You can actually just refer to compound linear inequalities to solve those, so we're not going to worry about those. Okay, so linear inequalities, and so these are the symbols we're going to use. And again, technically an inequality symbol is not equal to, but we're not going to use that one. So less greater than, less than, less, or greater than or equal to, less than or equal to. Okay, so just some reminders of property. So we have the numbers 3 and 4. Which symbol would I place between them? Okay, well, you're probably like, after 2 seconds, it's going to be a less than sign. And so again, if you need to remember, there's little teeth on the inequality. I learned it as an alligator. So the alligator always chomps towards the bigger number. Okay, okay, that's great. Technically, you could also do less than or equal to. That's fine. Now, I have the same thing, but I add 5 to both of the sides. Same thing exists. Okay, and if I subtract, well, actually this is the same, right? This is -2. The left-hand side is -2. The right-hand side is -1. And yep, the inequality is preserved. Okay, if I multiply, same thing. Okay, and again, if you just want greater than or less than, that's fine. Okay, and then division, same thing. Okay, but now, okay, so then here, I want you to pause for this. This ends up being -15. This is -20. So actually, the inequality reverses when you're multiplying or dividing by a negative number. Okay, so just to summarize, if we have two non-zero values, and we're given like A is bigger than B, and okay, again, C is a non-zero real number, and then D, it's saying here's a negative number, we have these summary statements. So we can add or subtract C to the existing inequality without changing the sign. We can multiply, and that's just non-zero. I should actually say non-zero positive. And that should actually go here. Actually, I'll just say change non-zero to positive. If C is a positive number, then we can multiply it at both sides and not change it. But if we end up having a negative real number D, that's when the inequality reverses. So if you'll notice, change from greater than to less than. Okay. All right, and then the other thing that we're going to be seeing with these is there's going to be some language associated to them. So we are going to put in, we can actually represent an inequality phrase in algebra, and using algebra, description, and actually geometry too. And this is just using the real number line. Okay, so for example, if we're given the algebraic form x bigger than 2, I like to draw the picture first. So here's 0, here's 2. Okay, remember my arrows. And then bigger than 2, we remember this as saying, okay, it's going to be 2 and to the right. And then also, another algebraic form would be interval notation, which you might remember is 2 to infinity. Okay. Now, how do we do the descriptive form? You can kind of see some examples. What language accompanies this? Well, you can just simply say x is greater than 2. You can say x is more than 2, right? Any of these will work, okay? I'll do one more, and then I'm going to have you finish the rest off, okay? So x is at most 3, x does not exceed 3. So again, I go to the diagram right away because I need to see this thing. Okay, so there's 0, here's 3. And if it does not exceed 3, that means, okay, no, it has to be to the left of 3 on the real number line. It has to be smaller, okay? The question is, can I have 3? Well, it says it does not exceed, so it can be 3 or less, okay? And also remember, we would use a bracket for this one, and so you can use dots or brackets. I forgot to say that up here. Here it would be a parentheses, okay? And so here this representation would be minus infinity to 3 with a bracket, okay? Now pause the video, try these other ones, and for this last one, I'm going to put that in a quiz. So I'm going when you resume the video, you'll see the answers except for that box. And here are the answers that I came up with. And again, we're going to do that next one in a quiz. So take a look at these and verify that these are similar to what you have. Maybe you have a slightly different drawing, like you numbered all the ticks in between 0 and 5, for instance. But we'll do a quiz right here and then move on to the next video.